Today we're going to do an overview. We're going to just try to touch on the highlights. There's been a lot of new activity looking at the project, and oftentimes we go a little bit deeper into the weeds on the technicals. But today we want to kind of just give an overview for people that are new to kind of see what the main points of Quai are. And so what is the objective of Quai? The objective of Quai is to build the money for the information age. And to do that, we need three things. We need scale, a sustainable monetary economic system, and decentralization. How do we go about achieving scale? To understand how we go about achieving scale, we first need to understand the requirements of scale. And looking at electronic-based transactions and people that have access to the internet, we can see that there's roughly about 8,000 TPS in the current electronic payment systems. And so we can roughly get to the fact that we need about 50,000 transactions per second if we want to function as money worldwide. How do we go about it? Quai introduces a multi-chain architecture. So unlike a traditional blockchain that you see on the left, which is a sequence of single blocks, one pointing back to the last, Quai is a hierarchy of chains that is merge mined, and it is able to dynamically increase the size of the hierarchy with demand to increase transaction throughput. So we have sort of three levels here: prime, region, and zone, that composes Quai Network. And in this example, we have a 2x2, what we would call ontology, but we can support 3x3, 4x4, all the way out to 255 zone shards. What is Quai actually doing to achieve our goal of 50,000 transactions per second? There's really three things that we can do using the hierarchy of merge mined chains that no one really else can do. The first one is we can shard the system. So instead of every node needing to keep the state of all the system, they can keep a subset of the state just for the zone blockchain that they're processing, rather than having to keep the state of all of the system at once. So we can decrease the amount of state people need to keep. Implicit to that, we're also threading when we create shards. So we're also decreasing the compute that's needed in any given node, as well as the bandwidth requirement for running a node. Now, sharding can potentially provide a 100x increase in throughput, but there's some challenges that go along with sharding. So how do you shard state without sharding work? As well as how do you create objective inter-shard references that properly order the transactions between the shards? The next thing that we can do that offers about a 10x improvement in throughput is subnets. So in Quai Network, we have an incentive for miners to not just mine, but to also topologically optimize themselves to create low latent sets of peers, which will create subnets. And creating subnets allows us to decrease bandwidth as well as decrease the amount of compute that's necessary. The question about subnets, though, is how do you incentivize those optimal subnets, and then how do you prevent network partitioning? The last thing that we can do to increase throughput by about 10x is something called streaming. And the idea here is, instead of computing the state of the blockchain in bursts, we can introduce mechanisms that allow us to perpetually compute state updates, even though they don't become canonicalized until a block is produced. But in doing that streaming, we can decrease the bandwidth necessary in the system, and we can also decrease the compute necessary in the system. However, to be able to do streaming, we need to be able to decouple the consistency of the network with the consensus in the network. And we also need to have a process for statistical pre-compute. In traditional sense, you can kind of think of this as speculative execution. Now, one of the ways that we go about solving these problems is our novel consensus mechanism called POEM, or proof of entropy minima. And proof of entropy minima is the mechanisms by how we can shard state without sharding work. It allows us to create objective inter-shard referencing. It's also the mechanism that allows miners to be incentivized to optimize themselves into subnets, and it's also the mechanism by how we prevent network partitioning. And then in terms of streaming, there's two pieces that we need to do that. One of them is POEM, and then the second is what we call mine transactions. Mine transactions actually allow us to improve upon not only the resilience of proof of work, but improve upon the resilience of POEM from attackers. It allows us to increase our finalization times, decrease our finalization times, and it also allows us to have objective transaction ordering within a block, which leads to the mitigation or elimination of miner extractable value, or MEV. But that is required to sort of get statistical pre-compute and speculative execution. So what is proof of entropy minima? This is very, very high level. There's actually presentations on each one of these topics if people want to dig deeper. But proof of entropy minima is the concept of using the intrinsic entropy that a block reduces from the possible paths of execution of the chain to uniquely weigh and choose the head of the system. The benefits of doing this is it allows single round consensus. And when I use round here, I'm not using the information science terms of round. What I'm saying is there's one round of communication, meaning if I find a block and broadcast that block, the act of broadcasting that block puts everybody into consensus. So we don't have to talk to each other. We just have to broadcast to each other to reach consensus. This is the mechanism that enables us to both shard and scale really without limit. The properties of POEM that we get that allow us to do some other interesting things with the system related to economics is that the cost of a hash here is linked to electricity cost, and the entropy, which we measure in bits, is linked to the square of the users. So the entropy is really a measure sort of the network value in some ways, and the difficulty is a measure of the cost of production of a hash. So hash is a proxy for mining cost, and bits is a proxy for network value. So that's sort of an overview of the technical mechanisms that we use to scale. And like I said, there's whole presentations that deep dive on each one of those. But for now, we're going to move on to monetary economics. And when we talk about monetary economics, because our proposal is that we can build money for the information age, we need to understand what the properties of money are that we need to have a sustainable monetary system. So a lot of these things have been presented before in terms of the sort of 7 properties of money, and some blockchains in the past have been able to answer some of the questions of achieving properties of money, specifically durability, portability, and divisibility. However, where current systems have fallen short are fungibility, scarcity, acceptability, and transferability. So in terms of focusing on those, we need to create fungibility tools, specifically in the base layer if we want to have fungibility in the system. To achieve scarcity, we need a long-term economically sustainable model. Specifically here, if we look at Bitcoin, everyone says that there's 21 million Bitcoin and there will only ever be 21 million Bitcoin. But there's many conversations that have been going on over the last year to 18 months, specifically surrounding the fact that the mining economics doesn't seem to continue to work out with continued halvenings, and to maintain security on the chain with limited transaction throughput generating fees, there may need to be a change in the economics of Bitcoin, specifically creating ongoing inflation and violating the 21 million Bitcoin cap. So if you want a system that has a supply that approaches a number or sort of stays within a bound, you need to have fees really to generate revenue to pay for the security long term. In terms of acceptability, one of the items that hasn't really been addressed is how do we create a stable token, or a token that can be used for a unit of account as well as a median of exchange in the base layer. If we look at something like Ethereum and USDC, it has quote unquote a stable token because you can use USDC to denominate goods, and if it weren't for the fees associated with Ethereum, you could use it as a medium of exchange. However, USDC is an extrinsic token, so the ability of creating that stable asset is creating trust back into the system, specifically the banks that are custodying the money, as well as the organizations that are running USDC. So that's like not a great system to have. So the question is, can we create a stable-like token in the base layer that's endogenous to the system that can function as a unit of account and a medium of exchange? And then the last question we need to look at is transferability. Specifically, in a decentralized system, people can't scale, and to be money, we need to maintain stable low fees. And to do that, you need to be able to scale supply of transaction throughput with demand. So we're really trying to achieve three things. We're trying to get all of these properties of money so that we can have a unit of account, a medium of exchange, and a store of value, all endogenous to a single system. And this brings up this concept of Gresham's law. And Gresham's law actually dates back originally in reference to, I think, about 800 BC. But the idea here is that inferior money drives superior money out of circulation. And to sort of expand upon that, Gresham law says if you have multiple forms of money in a system, one of those forms of money will be preferred and the other form of money will be non-preferred. Gresham refers to these as superior and inferior currencies. And an example here would be having specie coin, so a coin that's minted from gold or silver, which has intrinsic value, versus coins that have no intrinsic value themselves, but only face value. And there's an example here of this with the Liberty dollar that was 90% silver versus the post-1971 dollars, which are copper, nickel, and zinc. Obviously, we don't see a lot of silver dollars circulating because the intrinsic value of the metal is greater than their face value, so those are ported out of circulation, because if you had a silver Liberty dollar or a non-silver Liberty dollar, you would choose to circulate the latter over the former. Thus, the latter is the inferior form of money and the former is the superior form of money. Now, in cryptocurrencies, we've kind of created superior forms of, I wouldn't say money, but we've really created stores of value. So if you look at Bitcoin, people hold Bitcoin, but very often people will choose to transact in dollars. There's a couple reasons for this. One is Bitcoin isn't a good unit of account, and based off the fees, it's not really a good medium of exchange. What it is pretty good at least in the short to mid term, is being a store of value, meaning it's scarce and it holds its value, or its value goes up over time. However, in the long term, because people can't spend Bitcoin, even if Bitcoin could scale, there would be a limitation on the number of transactions that people would actually conduct in the network, assuming that an inferior form of money, i.e., say the dollar or another form of fiat, exists. So even if Bitcoin could do 1,000 TPS, there would still be a preference that if dollars are in circulation, to spend your dollars before spending your Bitcoin. Thus, there'll be a cap on how many transactions are put into the network. So another way to put this is deflation encourages hoarding, which is bad for our long term. But if we look at the dollar, inflation discourages hoarding, which is bad for short term and adoption. So the idea here is what Gresham is really setting up for us is that we sort of have a paradox around money. We're trying to simultaneously achieve two things, something that is good for adoption and wants to be hoarded, but also something that can set up sustainable long-term economics by encouraging transactions. So the question is, how can we design tokenomics to sort of reconcile this paradox of this duality of needs of money in a monetary system? And the simplest solution that we've come up with to meet the six additional requirements here is that we need a two-token system. So one token would be deflationary. You could think of that as gold. And the other token would be inflationary, but would have a relatively stable value, such that it could be used as a unit of account in the medium of exchange, much like the dollar. The net effect is that we can create an incentive to adopt the system, i.e. having something that has a more traditional deflationary characteristic like Bitcoin. And we can also have something in the system that encourages transactions as a unit of account and medium of exchange so that we can ensure long-term system sustainability. So users will always have an incentive to spend, and they will also have an incentive to hoard, depending on which token they're using and which what their use case is. But most importantly, in the long term, this should create fees which are adequate to reinforce the incentive design without an inflationary reward. So the two token system solves Gresham's paradox while also creating the desired properties of money. Now, specifically in our system, the two tokens are called Quai and this is actually an old slide, Chi. There's a typo there. And the Quai token is a deflationary token. It has smart contracts. There's implications around privacy associated with that. And you would think of this as the preferred or superior form of money because it's hoarded and it's relatively deflationary over time. Its block reward will be related to or proportional to the log of the difficulty of the system. And the Chi token is an inflationary token. It's relatively stable. It will have fixed denominations. It would be what we would call the non-preferred or inferior form of money, but it's the one that you would want to circulate, denominate goods and services in and also use as a medium of exchange. And with that, let's talk about sort of our last requirement, which is how do we maintain an objective and decentralized system? To understand how we do that, we kind of have to better understand proof of work as a process of mining. When I talk about POEM is actually a new consensus mechanism, but it is work-based. So it carries forth the characteristics of work in what we think is a more efficient manner. But what are we achieving with work? We're achieving independent economic commitments to a set of transactions, which is getting added to the blockchain. The way that we do that is through the process of mining. So when a miner mines, they have the current chain state, and they will organize a set of transactions to propose a new block, and then they will generate a nonce to grind that proposal to generate a hash which meets the difficulty requirement of the chain to create a valid block. Once they find a valid block, they'll broadcast that, and then the process repeats. Now, the key characteristics of work-based mining is that every block is a unique economic commitment, meaning I can't simultaneously commit to the sort of two sets of things. I have to be making a commitment. I can't make a commitment and then mutate that commitment. Every hash that I do is a costly commitment. And what I mean by that is we can't sort of simultaneously commit to two different things at once. So if I commit to this set A of transactions, I can't then take that same sort of nonce and make that commit to set B. And that sort of unique economic commitment is how we create expense at depth, which is how we get immutability of the ledger over time. So this is the mechanism by which we get permissionless consensus, i.e. ordering of transactions as well as validity of those transactions against the set of rules. So mining is an economic commitment attesting to validity, and it creates immutability. Now, we want to contrast this with proof of stake. Proof of stake makes interdependent attestations to a set of TXs. So if we look at the process of staking, the first three parts are the same. We have the chain state, we take a set of transactions, we order them, and then we propose a new state. The difference here is that instead of doing work on that state, we sign a message attesting to that state. We then broadcast our attestation. We gather a quorum of signatures, which eventually creates quote unquote a valid block or state transition, and then we repeat the process. The key characteristics here is that every block is an interdependent attestation, and this is a social consensus, is the guarantee of finality with depth. So there's no objective or economic mechanism here. This is often referred to the nothing at stake problem in proof of stake, and it definitely exists and it definitely has not been solved. Also, this is a permissioned form of consensus, and the reason it's permissioned is because you must have stake to participate, which means the current people that are staked are required to agree to let you to stake to also participate as a staker. More importantly, too, that starts to elucidate the fact that if the majority of stakers want to, they can change the rules in perpetuity, whereas contrasted with a work-based system, if you had a majority of hash rate, the majority of hash rate can't necessarily change the rules. They would only be able to censor some transactions for some period of time, but they wouldn't actually be able to mutate the rules of the system. So the key characteristic here is that attestations are a social commitment attesting to the validity and agreement, which is not an objective commitment. So really the point here is that proof of work versus proof of stake is the difference between an objective system versus a subjective system. So proof of work is making an objective economic consensus. It's creating immutability with history, not just an economic immutability, but at some point bound within the physics that we have on Earth and the computers that we could possibly build as humans, there is actually immutability to the ledger. It is a permissionless form of consensus because anybody can create a hash and participate at any point in the network, regardless of what has happened before. And it is decentralized. And one of the big key characteristics that people often overlook with decentralization is reliability. So I actually looked and I was trying to figure out the last time Bitcoin went down, and the only reference I could find was in 2013 when there was an issue during the update of a hard fork, which obviously we can contrast with proof of stake based systems. With proof of stake, we have subjective social consensus. Only the coordination cost is required to change history. So at any point in the future, if I can convince the majority of validators to sort of change the history going back an arbitrary depth, I could do so, and my only cost of doing so is the coordination cost, because the cost of the creating new signatures on a new history is effectively zero. And this is also, again, permission consensus, and it's centralized, and i.e. less reliable than a decentralized system. And I also just was looking, I asked ChatGPT, and it told me that there have been 6 major outages in the last 2 years for Solana. And you compare that to the one outage that happened over a decade ago with Bitcoin. And the last thing we should talk about here is our distribution mechanism. So how are Chi and Quai distributed? They're distributed through mining. So the only way to sort of achieve the characteristics of this hierarchy of merge mined blockchains and consensus and sort of this infinite level of scale is using POEM or proof of entropy minima. The other reason mining is great, though, is because it is distributed and accessible worldwide. One of the reasons that we picked a GPU algorithm is because we think GPU algorithms are more economically diverse and more readily available globally. So it provides better access to the system and a more diversified mining base. Now, that being said, we should talk about the mining market and why the mining market is important to maintaining a distributed system. Specifically with GPU-based mining, it's a competitive it's competitive in the long term. So no single entity will end up controlling the network. You'll have many entities that participate, but no single entity can really dominate the network. And this fragmentation is what prevents changes to the system. So the more fragmentation you can get in your mining base, the more disparate countries that are doing it, the more disparate economic interests that are doing it, the better off you are in terms of achieving an ossified set of rules that won't change with time. And an ossification of the rule set is indeed what you want for the ideal form of money. So mining, specifically GPU-based mining, creates a competitive market so no one ends up controlling the system. And with that, I'll take questions.
The first question, Dr. K, is how do you think about fees in Quai Network, and how will they be? Will they be high, low? What's the goal there?
The goal with Quai Network is that our fees for normal transactions should be around a penny. And they should be a penny today, a penny tomorrow, and a penny in 10 years. That's actually one of sort of the important differentiators, is because the hierarchy can expand its ontology with demand. We can make guarantees of being able to maintain that low fee structure in the long term.
Someone says, do all miners have an equal chance of earning rewards? I think that might be a good kind of way to talk about proof of work in general and just the concept of block rewards and who gets paid out block rewards.
Yeah, so the idea with work is the likelihood of you winning a block is proportional to the number of hashes that you've done in the system. So the more hashes you do, the more likely you are to win. Effectively, the greater proportion of the total hash rate that you have, the proportion of the total hash rate that you have dictates the likelihood that you'll find the next block, roughly speaking. So, the more economic input you put in, the more likely you are to get rewarded. So that's why it's an economic commitment, and it's an economic consensus mechanism. It isn't a social consensus mechanism. So it's not one vote per person, it's one vote per hash.
Some more legitimate questions about the tokenomics model. Can you briefly explain the conversions between Chi and Quai and the purpose of them?
So the purpose of Chi is there is effectively an options game that is set up. So when miners mine a block, they can elect to receive their rewards in Chi or Quai. And there's kind of a natural conversion rate that's in the system that's based off the relative rewards, based off the present difficulty. The idea here is that Chi is issued proportional to the hash rate of the network. And in doing that, we create what's known as a Schelling point. So then the price of Chi should approach the price of a hash, and the price of hash is dictated by the cost of miners, and the cost of mining is dictated largely by the global average energy or electricity prices on a 1 to 3 year basis. So the idea here then is that Chi in equilibrium over time should approach the cost of electricity, or should be related to the cost of electricity. That being said, if we look at sort of energy in society and what role it plays, the pricing of most things are actually the input costs, and the input cost all comes back to the energy costs. So we think it's a very stable unit relative to the aggregate economy. And that's really the point of Chi. That being said, the reason you need conversion mechanisms is because the supply of Chi needs to both expand and contract with the demand for Chi if you are to maintain that stickiness back to electricity prices. So that's the point of having the conversions in the system.
Got it. Good explanation. And we've got a good question from Skinny here asking about the security budget stuff. How are we ensuring that Quai Network will still have miners online and that miners will be incentivized to mine 10, 20 years down the line when Quai emissions have been cut drastically?
Well, the emissions will go down, but ideally the aggregate rate of reward will go up because of fees, right? So the problem for Bitcoin is the inflationary rewards are a good flywheel to get people to start into the system and as a distribution mechanism. And then decreasing those rewards creates a deflationary system over time and creates scarcity. So that's also a good mechanism. However, because Bitcoin doesn't have the ability to scale, it doesn't have the ability to generate more and more revenue with time as more and more users come on. If it were able to do that, it would be able to generate fees that go to offset the need for an inflationary block subsidy. So the idea here is that in 10 years' time, if the network is doing 50,000 transactions per second, it means it's generating $5,000 per second in security budget, which would be more than ample to secure the network.
Got it. Makes sense. Another good question I see here. that maybe dives into like the Quai versus Chi chains and the differences in the shards. But can both Quai and Chi be used to pay transaction fees, or is one of them, an exclusive gas token?
So if you're transacting in Quai, you'll pay your fees in Quai. If you're transacting in Chi, you'll pay your fees in Chi.
People are asking, so in the docs it's specified that the conversion between Chi to Quai is possible natively in the protocol. Are we aware whether it'll be a two-way function or will just be one way? Or is that still up in the air?
So ideally it will be a two-way function. We're in the process of running dynamic models to make sure that the system is still stable with a two-way function. You don't necessarily need a two-way function. It will work with a one-way function, assuming that other things exist. So effectively, if the demand for Chi increases past what can be accommodated by miner choice in terms of minting new supply, that excess demand will eventually bleed off into alternative forms of quote-unquote stable assets, i.e. dollars and euros. From a system standpoint, that means that the system does become interdependent on these other forms of money. So ideally, you do want a two-way conversion mechanism, but like I said, we're wanting to make sure that adding that mechanism maintains stability under all possible conditions. So once we do that, we'll know if the conversion from Quai to Chi is going to take place or not.
Got it. So we've said obviously a lot that mainnet is coming this year, 2024, ideally in summer. Do you want to share a bit, maybe like what does the timeline look like for the upcoming testnets? Like what's in work that needs to be done for mainnet?
Yeah, so we have 2 more testnets planned. The really big pieces are really coming in this testnet, and we're still targeting this testnet for the end of February. Once we kind of have this done, there's a few outstanding pieces that need to happen for the Silicon Age testnet, but it's a much smaller set of items. The one that stands out to me immediately is just the introduction of merge mine transactions will be part of the Silicon Age. But yeah, the amount of development of new features between this testnet and the next one is going to be relatively small. There'll be a few, and then the majority of our time will then go towards increasing testing, conducting the audit, and pen testing the system, things like that.
Makes sense. And we've got a couple questions that I'll kind of all lump together into one. So regarding tokenomics, there is, as we mentioned in the docs, there is like a terminal supply of Quai, but it's not like a predefined fixed supply. So I guess could you add some clarity to, if someone asks you what is the total supply of Quai, what's your answer to
that? There is a number that exists that the total supply will approach that is based on how the adoption curve of Quai manifests. So it will approach a number. If it is adopted very quickly, that number will be higher. If it's adopted slowly, that number will be lower.
Got it. And then what would you say to Chi total supply? Is it just completely dynamic?
Yeah, so the amount of Chi relative to Quai is going to be based off the demand of Chi relative to Quai. My net expectation here is that sort of given the relationship of money or the medium of exchange or the unit of account that we currently have, and its relationship to other financial assets or stores of value, I would anticipate that, and this is just me, there's probably many arguments that could be made, but I would personally anticipate somewhere between 1% and 10% of value being in Chi. And obviously that will change too, right? So during different volatility environments and different expectation environments, right? That's a dynamic process, right? So much like you see the supply of USDC expand and contract on Ethereum during different times, you would have the same expectation for Chi.
Yep, makes sense. And then I think the last question, or maybe I'll ask this one and see if there's any more, but will testnet participant incentives have vesting? I don't know if you feel free to say we don't want to get into any of this right now, but what does vesting look like for people who participated in testnet or Galaxy or any of those other things, if you want to share?
I don't have the. This is determined. I don't have it in front of me, so I don't want to say anything specific to any specific group or what that vesting is. But there is vesting. Some groups unlock, I think at the beginning, and then there's different vesting schedules depending on the group. Yeah.
Makes sense. I think that's fair. We'll definitely, Skinny, as you said, we'll be dropping a ton more info about vesting, tokenomics, unlocks, all that, logistical stuff as we get closer to mainnet. Let's see. Kishore asks, difficulty is a dimensionless construct, so we map it to hash alone.
So difficulty itself is actually the measurement of the number of hashes to find a block. So if difficulty right now, I think in a zone is 120 billion, that means to find a block you have to do 120 billion hashes. There's one interesting follow-up that I'll just mention. It's a little bit technical, right? Got to get a little wonky, being me and all. The interesting thing about Poem and the weighting that Poem puts on the block, one is it's guaranteed to be unique. So every block or chain of blocks, that Poem weight, which is entropy, total reduced entropy, is universally comparable across block types and chains of blocks. So it allows us to compare 2 zone blocks to a region block to 3 prime blocks, and that comparison is always fair, so to speak. And the value that it's actually representing is the expectation value for producing a chain of any form that has the same, it's the expectation value on the number of hashes needed to produce a chain that has equivalent entropy as the one that we're comparing to. So, if I have an entropy of, 1 billion, so to speak, that's in bits. So if I take like 2 to the billion, that's how many sort of hashes I need to recreate that chain. So what we're actually doing is we're keeping a running total of the hashes that went into any possible block and then using that to choose which block we pick. That's just what we're talking about, what difficulty and what hashes are.
We've got a burning question from the audience. It's got like 10 thumbs up. People want to know. In terms of regulations, are there any problems for Quai's dual token model?
Presently, there are not. Even with the regulations that are proposed, there is no peg, there is no custodian, and there is no tie to any other monetary asset. So at least of our understanding of even proposals for regulations which have not moved forward, there are not currently any things that inhibit the 2-token model.
I can ask this one more. What do you think about ZK technology and how Quai can position itself into this new trend? Does Quai use ZK at all?
Yeah, so ZKPs are interesting. I don't think they're helpful to scale anything. They're helpful to sort of prove things in what I think is predefined sets of interactions. When you talk about using them to scale, you're talking about recursive ZKPs, but the ability to create and prove ZKPs sort of efficiently is about 10,000 times off of what it needs to be to go to a system of scale. if not more. So anybody that's talking about ZKs as a mechanism of scale is either introducing weak subjectivity, or they're just creating another constrained system. An example to expand on that is Ethereum basically failed at scaling. So they say that their scaling methodology is just the L2s are going to figure it out. And then they're introducing proto-dank sharding with enshrined rollups as their mechanism to enable the layer 2s. If I think we look at the throughput of Ethereum and we look at what you can do on a ZKP using current technologies, I think you could have liveliness if you could slot in, say, 100 ZKP rollup systems, which would all be different systems with different subjective security models, and fragmented liquidity, and each one of those could do about 7 TPS based off the validation requirements. So even if you had everything roll up into Ethereum, you'd still only ever get to about 700 TPS using ZKPs.
And then there's another good one that comes, but if you had to, what would you consider to be the biggest weakness of Quai Network, speaking to either tech, safety, decentralization, UX, anything like that?
Yeah. So, if we're honest about the system, right? There's a trade-off with scale, which is if you have a very large system, your cross-chain settlement time logarithmically increases with the size of the ontology. However, we need to unwrap sort of practical examples of what that means. So when we do mainnet, the plan is to launch with a shard. We anticipate that shard will be able to do somewhere between 500 and 1,000 TPS. So by the time we are 4 times bigger than BNB was at the height of the last bull cycle, we will need to expand to a 2-shard ontology. That will introduce a 2 to 3 minute delay if you want to cross those 2 shards. It doesn't mean that you won't finalize or you won't process the transaction on a normal sort of 10-second block time. It just means you won't be able to respend the transaction if it is cross-shard for 2 to 3 minutes. Okay, so let's take a greater extreme. Let's say that we end up having 50 shards and we're doing 50,000 transactions per second. That means that we've basically become money for the entire world. That cross-chain transfer time for a worst-case scenario for a far sort of cross-chain transaction, I think would grow to the order of 10 hours. But that's if we are functioning for money for basically everybody that has the internet. But that's the trade-off.
Fair. No, I think that's a good thing to go over is always, figure out what the weaknesses are, and there are always ways to address those. I think we've talked not super at length, but we've at least discussed like the liquidity balancing protocol that would allow.
Well, so the thing is, right? Like people are going to both economically and geographically optimize. So what will end up happening is if you have 4 shards in the world, there's going to be one for North America, one for South America, one for Europe, one for Asia. Okay, so only when you sort of transact outside of North America are you going to have impeded settlement times. And if you transact to South America, you'll get instantaneous sort of processing. The person that's receiving the money is just going to have to wait a little bit before they use it. This is exactly the same as having to do a wire or an ACH versus doing an in-person transaction. The difference being is that we can still guarantee way better settlement times of money in all scenarios compared to any other system that exists. And we're doing this in a perfectly decentralized environment, right? So we're not getting scale by centralizing, we're getting scale by decentralizing, right? Solana gets scale, one, by lying about their TPS by like 95%, which is a whole nother discussion. But the other way they do it is they just have massive computers that only a handful of people run. And that doesn't create economic diversity. That doesn't create an ossification of the protocol. It doesn't create reliability. So in all cases, as I measured, it doesn't create a monetary system. So yeah.
Another good question: how will shards be treated by centralized exchanges? How will they integrate Quai?
So they can choose to run as few or as many shards as they want. An exchange could simply run a single shard and think about that as the ingress point to their exchange. And then the people that want to deposit money from another shard will have to wait slightly longer for that deposit to settle and be usable on the exchange. And then exchanges which decide to manage more shards as more shards come into existence will potentially have a competitive advantage in the marketplace because they'll have faster deposit and withdrawal times.
Got it. All right. Well, I do think that is all the questions that I'm going to go through. I will say we had a crazy audience today. I think the Discord voice channels max out at 999 people. I think we got pretty damn close to that today. So we will definitely be exploring like the YouTube streams and stuff for future calls. But yeah, thank you so much for everyone for joining. We really appreciate y'all. Even if you're here for a Galaxy task, we hope you learned something today and are maybe a bit more interested in Quai. So Dr. K, appreciate your time as well. It's always interesting doing these calls and discussions and having you answer questions from the community. Do you have any final thoughts?
Yeah, no, I mean, it's great to see the community grow. I appreciate everyone for coming, wanting to learn about Quai and how we can create, a new decentralized money system, which hopefully will sort of answer the promise that was originally made by Bitcoin. Yeah, so looking forward to it. We're making great progress on the tech side. It really feels like we're skiing down the hill, not climbing up it anymore. So excited about improvements coming to Golden Age really soon here. Yeah, so thanks everybody.